Assalamualaikum warahmatullahi taala wabarakatuh. How are you? Okay, semua. Alright. Today I will continue 13.3, 13.4. So hopefully you can cover up to 13.4. We are done with 13.2. Let me give you some homework question first. This is on chapter number 13. I'll give you some questions before. Tadi soalan. This is homework questions. 13.2. You do 1, 2, 4. Anak siapa tu? Anak ke adik? 13.3. 13. Oh, this is 13.3. I'm sorry. 13.3, you do just 3 questions, 1, 2, and 4. And then 13.2, okay, which we have finished, but I have not given you any question. So 13.2, 2 to 6, and then 12. And then 13.4, question 22, 24, 25, 31. Okay, for these questions, you have to find both consumer surplus. This time we're going to discuss today. Consumer surplus, producer surplus, and then sketch the graph. Okay, just sketch, identify the area. Okay, all right. So let us begin with 13.3. Now 13.3 is extension of 13.2, where you want to find an area, all right, between two curves, you know, 3 curves. So it's not directly the area under one curve, but it is an area identified by more than one curve. Okay, all right. So that is 13.3. So we call it area between curves. So 13.3, 13.3, area between curves. Kita selalu nyebut dua curve, between two curves. All right. Let us start with an example. Just to idea. Okay, I draw one graph. Sketch one graph. All right. Now let's say I have here y equal to everywhere. And this is the origin. This is here x0, or if you follow the book, it's B, and I'm sorry, A, that's B. So the interval is 0, x0, or you can use A, B. Zero x0, bukan 0 x0, silap. Dia pakai x0 to x1. So 0 to x0, 0 to all the notation that I use is x0. Okay, x0 to x1. The book use A, B. So sama je lah. Okay, x0, x1. All right. Now, if you look at the specific example for this one here, it's from 0 to x0. All right. X0 dengan X0 ni is not related. Okay, X0 here, X0 over there, they are not related. Just a general notation. Okay, I can use another notation. Yeah, maybe we can use another number rather than using X0 can be confusing. So let's say we use X2. Okay, so X2 here. So X2 is the specific interval. Right? As per that example, 0 to X2. In general, interval X0 to X1. Okay, X0 to X1 can be any value. All right. So if I want to find this area here, all right, this area here, call it area A. How can you find area A? Area A is simply what? Is simply the area under what? Under f of x from where? From 0 to x2. Okay, so area A is what? Is the area under f of x from 0 to x2. So that is the integral from 0 to x2 of what? Of f of x dx. Okay, so in other words, the area under f of x from where? From 0 to x2. So the interval is 0, x2. Okay, so that is area A. All right, now let me draw another function. Suppose we have another line. All right, call this g of x. And then what I do, I want to find over the same interval from 0 to x2, that area. Okay, the area, I shade the area here. Now the area is shaded in red. Okay, how can we find the area in the red? I call this area B. Okay, how can I find the area B? Just look at the graph, just tell me. How can I find the area B? Just tell me the area under what function, from where to where. Okay, somebody. The area B, okay, the whole area here, from the area under the G of X, under that line. Okay, so how do you find that area? Okay, Iman, how can you find the area? Ain Dalili. How can you find the area B? Okay, somebody lah, siapa pun boleh. Cepat. Just try lah. Okay, how can I find the area B?
Integrate from 0 to x2.
Integrate from 0 to x2. Okay, what is the line? What is the function?
Y equal to gx.
Y equal to gx. Okay, so the area B, good. Okay, senang ya. So the area B is what? Is the integral, or the area B is the integral from 0 to x2 of what? Of g of x. So that will cover the whole thing. Okay. All right. So if you want to find B, that is simply the integral from 0 to x2 g of x dx. All right. So the area under a curve is the area between the curve to what? To the x-axis. Okay, to the x-axis. Okay, all right. Now, suppose I want to find something between A and B. I just want to find this area. I shade it in blue. Ni je. Okay. Kita nak benda tu je. Tak nak banyak. Okay, I want to find area C. All right, now, how can we find area C?
Minus area B minus area A.
So you have to minus BA. Betul tak? Area B minus area A. Right, C is equal to B minus A. Bagus, betul tu. Saya pun tak fikir, saya fikir integral je. I have not thought about in terms of the area. So what you say is a good idea. Saya pun tak terfikir gitu. Siapa nama tadi? Siapa? Who was that? Siapa tadi yang cakap B minus A tu? Cuba. Ada sekali, saya dah tengok nama. Siapa nama? B minus A tu. Siapa cakap ni? Siapa? Cakap nama. What is your name?
There's 2 person.
No Alia.
And,
No Alia.
and then there's another person. We talk at the same time.
Siapa lagi seorang? No Alia dengan siapa? Idea. Saya pun tak fikir gitu saja. You know? So thank you. No Alia. Siapa seorang lagi? No Alia dengan siapa? Okay.
Farhana, sir.
Farhana. So if you do that, you senang sikit nampak. Right? So area C is the difference between B and A. So that's what we mean area between curves. So let's use that. Betul. Saya dah bagi dah area A, saya bagi area B. Tapi I didn't relate to that thing. I just want to say in terms of integral. So area C is equal to area B minus area A. All right? In terms of integral, there will be what? There will be the integral from 0 to x2 of g of x. G of x is function yang kat atas. Ke f, g. Okay? G of x dx minus the integral from 0 to x2 f of x dx. So that is area between two curves. That is an example. All right? So we identify the area that you need, that you want to find, and then we have to formulate how to find it by making use of the functions that are available, and of course the interval. So you have to find probably sometimes, what is the interval, and then you have to determine what are the functions that are involved in order for us to find that specific area. Okay, all right. So okay lah. Okay, itu. Probably we look at an example. Now, that's the idea. So let us move a little bit more detail. So what I want to do here is I will draw again two curves. Okay, so let's say this is y equal to f of x, something like that. This is y equal to g of x. Okay, number one. Suppose I want to find this area. I call it area A. Okay. How can you find area A? Tell me, what do you need to know? Okay, what do I need to find in order to get the area A? Okay, cepat. Okay, just tell me, area under what curve?
Under fx.
Number one is the area under f of x, okay? But it's not just area under f of x because you only need that part, okay? If you are talking about area under f of x, that will cover everything sampai ke bawah, okay? You don't want that. You only want that part. So what do you have to
Find the intersection point first.
first, you need to find the intersection, okay? Why? Because that will give you the interval, okay? So number one, you need to find, we call E, all right? Normally we call E is simply what? Simply the intersection of the two functions, fx equal to gx, all right? So in other words, we need to find equilibrium, we call equilibrium, just intersection. So let's say the point is x1, y1, all right? So let's say I got that point, x1. So now you already have the interval. The interval is from 0 to x1. And you already say it's the area or it's the integral from 0 to x1 of f of x. But that is not the whole thing. Okay, it's only part of the story. So what is the other half? Because you want to find A, all right? You want to find A, not you don't want to find the whole area. So what do you have to take care of?
The integral 0 to x1.
Yeah, of course, the integral of 0 to x1 of f of x. Okay, that's one half. What is the other one? You have to take out some area.
0 to x1 or y equal to gx.
You have to take care of what? You have to subtract the integral or the area under g of x from 0 to x1 because we only need that area A. Okay, so you have to take out area here, area bawah. Okay, area bawah, you have to take out this one. And the area below is the area under G. So how do you get it? I take out everything. I just want to show you the thing. So the area A is the difference between the integral under F and the integral under G. Okay, because the area, this is our line G. Okay, G. So area A is equal to integral from 0 to x1 fx dx minus the integral from 0 to x1 gx dx. Okay, so here we're talking only about integral. Of course, you can relate to the area. All right, the area will be the integral. So A is the area under F. Okay, subtract the area under G from 0 to x1. Okay, any question? All right, so I'll give you another one. Now, suppose I want to find, so when you get the equilibrium, you got that y1. Now say I want to find, now area A is the whole thing, okay? Now I want to find only the one that I shade in red. Call that area B. Then I want to find out area B. Okay, look at the graph. All right, identify the interval, identify the functions. Now, do we have to subtract? Do we have to add? All right. Okay. Now, what integral involved? to get the area B.
fx.
Number
0.
1 is the area, is the integral under f, okay? Area under f from 0 to x1. In other words, the integral from 0 to x1, f of x, okay? But that is only half of the story, half of the area. What you want is B, okay? B is that triangle. So you have to take out something. What do you have to take out?
The area of y1 times x1.
You have to take out the area under y1. All right, that rectangle y1 x1. Okay. Anybody not clear? So that would be our area. All right, now you know the interval is from 0 to x1. And of course, you already have find equilibrium. Okay, so now I want to find area B. So that area B is equal to the integral from 0 to x1, okay, f of x. You have to take care of the rectangle. Okay, rectangle tadi y1. Okay, y1 bawah here. So rectangle y1 times x1 is the area of the rectangle. It's simply x1 y1. All right, that is the area of the rectangle. Okay, but in terms of the integral, what is the function? The function is the constant function y1, the x from 0 to x1. Okay, so if you do that, we'll get the rectangle. But we are using integral. The integral of the horizontal line, y1, that line. Okay, the line is y1. So you take care of the integral of y1 from 0 to x1. So what you get is the area B. Okay, all right, good. Now I give you another area. Say now I want area C. Area C. Okay, C. How can I find area C? Okay, how can we find area C? Similar to area B, right? But it's the other way around. Okay, what is the larger area? Sometimes, you know, when you do this, if it is subtraction, you identify the larger area first, and then what is the area that you have to subtract? Okay, here, what is the larger area? Area under what?
y1.
Area under y1. Okay, because what we need is the C here. Okay, so you need the area under y1 from 0 to x1, or in other words, you need the integral from 0 to x1 of y1. That will be the rectangle. We know that already. But you don't want the rectangle. I want only that part. So you have to take care of what? I have to subtract the area under what? I have to subtract the area under what? Under G. Okay, under G of x from 0 to x1. So area C, okay, area C is the integral from 0 to x1, y1, the x, that is the horizontal line, the constant function. And I have to take care of the integral from 0 to x1 of G of x, f of x, f of x, g of x. G of x. So I have to take care the integral from 0 to x1 of g of x. All right. Okay, good. Okay, kita bagi satu lagi. Okay, one more. Now suppose I want to find this area. You tell. Suppose now I want to find the area. Nih, area. Okay, I want to find that whole area. A, B, C. Okay, now area D. Okay, how can we find area D?
Fx minus A.
Okay, area D. Okay, area D. If you have f of x, the area under f of x, that will be area under f of x. Will be area from 0 to. Okay, first you need to find that point. Okay, so first thing you have to find that intercept, the x-intercept of f of x. All right, so call it x2. So in order to get the area D, yeah, you want to find the area D. Okay, number one, it's not given. All right, so things that you are not given, you have to find x-intercept of f of x. So call it x equal itulah x-intercept kan. Right. So if you say it's area under f of x from 0 to x2, so that will be the whole area under f, the big triangle. All right. Now, if you subtract area A, okay, if I subtract area A, then what we will end up will not be D. We end up with what? With the area yang kecil tu je, comel. So kita end up area ni ya. Boleh tu ya. Okay. If you take out area under f of x, and then you take out A, kita tinggal ni. Kita bukan nak cari tu. We want what? You want that also. Okay? All right. So now, how? Good idea tu. Good idea. That is one of the function that is involved. So now, how?
Integrate gx
Okay.
from 0 to x1.
So, okay, that's number one. If I integrate from 0 to x1 dx, so I got the first part. All right. Okay. After that?
After that, find the distance between x1 to x2.
After that, we find the the other rectangle, the other triangle. So that is the area under F from where? From x1 to x2. So here you have to add. Okay. So you have to add because the area is two parts. One part is area under G up to here. And then the second part is area under F up to the end point. Okay. Because yang tadi itu betul juga. Bukan betul lah, separuh betul. If you do area under F, you take out the area A, then we only have that part. Okay. So we need to find the other area. So we need to find the other area. You can use also that thing. Okay. If you want to find the other area, you have to what? You have to do something. So you can make use of that. You know, you go home, you think about it. So we'll get the same thing. So if I use, if I use that thing to find the area, we use this. But it will be long. Okay, you want area D. So what? You have to take care the area under f of x minus A. Okay, minus A. Betul tu, minus A, area A kita dah dapat. And then what you will get will be the rectangle, that triangle. But you need to find that portion. So that portion, what is it? That portion is the area what? The area A. I have to subtract area under G. Okay, so we put a plus sign here. So I put bracket there. You have to put area A minus area under D. Minus ke? Area A minus area under G. Okay.
Sir, I want to ask.
Area under F. Jadi nak tengok. Boleh pakai F. Area under F minus A. So A and A. A and A. Ini cancel out lah. Tapi ini subtraction. Alright. So ini susah. Okay. So that one is difficult because you have to go macam you nak pergi ni lah, nak pergi ke Bentong. Okay, nak tolong orang banjir kat Bentong. Kena ikut Kuala Pilah, Seremban, masuk ke Melur, apa lagi. So penat. Alright. So the more, I'll come back to your question after. So the more direct one is the area under the G, okay, from 0 to x1. So it's the area under G from 0 to x1, G of x, plus the area from x1 to x2 under f of x. Oh, I forgot the x. Ini dah. So if you want to do from here, tengok, pening, susah. Okay, you have to plus, minus, minus, plus. Sepatutnya kita dapat minus plus kan. So maybe you check balik. So senang cerita ni. Alright. Okay, what did you want to say?
Sir, I want to ask about the A area.
The A area. Okay.
Sir?
Okay, A area. Oh, the A area. A area, I'm sorry. So you cannot use the A area because the A area is only that I thought the area A area up to the x-axis. Okay. So yang benda kita buat ni tak pakai. Tak boleh pakai. Because area A tu, I was mistaken. Area A tu in fact is just that part only. Okay, area A tu yang ni. Okay, area A ni yang the triangle bounded by D of x, F of x. Betul tak? Itu area A. So yang saya cakap tadi tu boleh pakai. Sebab ayat saya, because what I thought was area A is the whole thing from f of x. Okay, I thought it's the area under f of x from 0 to x1. But I was wrong. A was not that. Okay, thank you. Ini boleh pakai ni. Alright, so to get area, to get D, this is the right one. Okay. Okay, thank you. Okay, anything else? Betul lah kan? Area A tu yang that portion, not the whole thing. I was thinking area A too is the whole thing. So the part that I was saying, all right, that you get that small area too, semua tak boleh pakai, salah belaka. Okay, because my assumption of area A was not correct. Okay, because I thought area A was the big area. Oh, sorry, yeah. Sorry, I hope I don't confuse anybody. So that was okay. Alright, clear. Okay, good. So
Sir, so
yeah.
we can use fx minus a. Fx integral of 0 to x2 minus a. We can use that.
Tunggu sekejap. Betul juga ya. Okay, tunggu. Alright. If you get the area, the integral from 0 to x2 f of x, I got the whole thing. Okay. And then I take out the area A. Now, thing is, here we assume that I know area A. Okay. Suppose I do not know the area A. All right. So if you do not know the area A, then you are going the long way. You need to find area A. How do you find area A? I have to subtract area under F, from 0 to x1. And then I have to subtract the area under G from 0 to x1. Then only I got A. So it will be a long method. What you're saying is correct. Okay, I think you're right. Area under F from 0 to x2, that's the whole thing, you minus A. You are correct if we know this already. Okay, if this is known, area A lah ada, so senang kita. But if area A is not known, okay, if area A is not known, what you need is only D, and you are not given area A, then the best, okay, the best or the best solution will be just area under G plus area under F from the different interval. Okay, you can do that only if we know already A. But if you don't know A, then you have to find A. Panjang cerita. Okay, so the most direct one, would be just the area under G from 0 to x1 plus the area under F from x1 to x2. Okay, all right, okay, good. So I will give you another area. Okay, last one. Okay, another area. This is the last part. All right, this one I want you to do at home. I want you to find the area. Okay, and the area will be this area. A, B, C, D, E. E is already equilibrium, so I call this area F. Okay, this area F may involve more than 2 lines. Okay, I have 3 lines. So you do this at home. You have to have some time, think about it. Okay, you don't have to compute anything. Just identify what are the intervals, what are the intervals that you need, what are the functions, and then how can you get that area F. All right. Okay. So let me give you one example. Okay, I want you to do this example. I'll give you a simple example. Let's say I have the following functions. This is x, y, 0. Suppose this is y equal to 3x plus 1. Then another one here, y equal to 10 minus 4x. 10 minus 4x. 10 minus x. Okay. All right. Now I want you to find this area. Okay, just one area. All right, just one area. But I will, afterwards I will give you more. So this example and the function I give is simple example, simple function, so that you can find the points or the interval very easily. So find the area. Okay, do it now. I'll give you 5 minutes. Okay, I got it. So first, what you need is you need to find that intersection. Okay, so we call it that point E. So number one, in order to find A, all right, to find A, what I need, number one is you need E. What is the point? E. If you do the intersection, what do you get for the value of X? Anybody get it? Let me know.
Be equal 1. It will be equal 1.285.
285. Everybody got 1.285? Okay, so that is correct. Okay, assume that's correct. Lah. So in order for you to get the area A, what you need is only that point X. You don't need the area Y. Of course, you can find the point Y. Lah. So you do the intersection, 3x plus 1 equal to 10 minus x. All right, or you should write here, maybe I can put here need f of x. This is g of x.
No, sir, it's mine is wrong. I do 4x, not only x.
Equal to f of x. Okay, what is the value?
No, mine is wrong. I use 4x, not x.
So what is the right one? So yang tu that is not right. So get me the right one.
Okay.
9/4.
9 of 9. 9/4.
2.25.
9 over 4 is 2.25.
2.25.
Okay, so you work this out, you get x equal to 2.25, and then you find y lah. Okay, but to get that interval, or to get the area, you don't need the y. So what is the area A? The area A is simply the integral from what? From 0 to 2.25 of what? G of x. Okay, I write G of x first, so that you know the upper function. Okay, so sometimes instead of using y equal to something, you use f of x, g of x, so that I can differentiate. Okay, I can differentiate the function. And then I have to take out the integral from 0 to 2.25 of f of x dx. Okay, and that will be what? That will be area from 0 to 2.25, 10 minus x dx minus the integral from 0 to 2.25 of 3x plus 1. Make sure you put the bracket for the whole thing, okay? Because the function is not just one term. The function is consisting of more than one term. So put the bracket to indicate the equation that we need to do. Okay. So now instead of doing the two integral, you subtract first, because you see here you got x and 3x, so that can be simplified. And then I got 1 and 10, so that can be simplified. Okay, so simplify that. All right, so finish this up. All right, so that is an example. And you know what? I think the quarter, and yeah, probably you can find this. So another area that you can find, okay, since I give you already the point E. Okay, so now you will, okay, so I want you to do this other area. Okay, you find that area. Find that area. So the area B. Okay, and then alang-alang buat kan. Kita buat dalam satu. Okay. Another one is area. Okay, good. So that is the example. Okay, just do the other two areas. And then for your practice, I give you already some questions. All right, so we'll do that one. Then that will do it for the 13 point. Okay, I need to I need to inform you this. If you look at application in the 13.3 and 13.2, okay, let's look at 13.2. 13.2. Look at example 6. Okay, and then example 6, example 7. Okay, and then you look at 13.3. Sama je. You know, we have a similar problem. So 13.3, 13.2. Okay, so 13.3. So these functions that we are talking about involve exponent e. Now, I didn't do this one. So what I need to do, after I finish this chapter number 13, I will spend some time, you know, doing the derivative and the integration. of the term E, okay? So that we can be able to look at examples like income and future income, present income, okay? So I need to do that. So I will do that when you finish this chapter number 15. Okay, any question? Okay, all right, so we are done, 13.3. So 13.3, I'll give you already some questions. What I would like to look at next is 13.4. Okay, so another application is 13.4. So you have also here, present value. So we cannot do that now. Okay, so we will do the E, and then I will come back to that. So the application that I would like to look at in 13.4 is the one concerned consumer surplus, CS, and producer surplus, PS. Now again, this is economics application. So if you are doing economics, this is very relevant to you because it's an important concept in economics. All right. So we're going to do the consumer surplus by applying the definite integral because it involves area between two curves. So here you're talking about area between two curves. Okay. Let's get the idea first, economic idea. What is consumer surplus? So in order to get the idea of consumer surplus, producer surplus, we have to go back to the market. Okay, look at the market of a good. Say now, okay, now we must durian. So now, durian, okay, musangking ke IOL, alright. So let's say market of durian. If you look at the market, you have the demand function and the supply function. So call it the demand function. Call it df, and then the supply function. There's a way, so just x. Okay, so demand and supply. So just call it d and x. And of course, the demand function, p function of x, and the supply function, you also specify that p as a function of x. Okay, now under the market, this is the market. Market of durian. Anybody non-Malaysian who do not know durian? Durian is a Malaysian fruit. Now, if you want to know, you Google. Okay, you Google durian, or you go, or if you are staying in Gombak, just go to maybe Greenwood, kemana-mana. I think they are selling durian right now. So durian is a kind of fruit only unique to part of Asia. And then you get the equilibrium here. I have the market quantity, call it X1. And then I call it X0. And then you have the market price, call it PE. So for equilibrium, okay, here we know already for equilibrium, demand equal to supply. You got the equilibrium. Say equilibrium is XE. Okay, the market price, market quantity. So in the market, what you get is this. You pay PE. Okay, the consumers pay PE. What do they get? We get XE. Okay. Similarly for the firms will give you XE. What do they get? they get the price PE. Okay. Now, in terms of the price, you get XE. Now, how much is the total expenditure to the consumers? How much do we spend? How much do you spend on durian? The price is the price. Okay, price is something per unit. So let's say the price for one durian, kita buat senang, kita one durian. Let's say 30 ringgit. Okay, murah ke? Nah, kita hentam matahari. Okay, sekarang ni harga kayangan. So kata 70 ringgit one durian. And the quantity in the market 1,000. Okay, now how much the consumers spend or the expenditure on durian? How do you get the expenditure? How much do we spend on durian? The price is 70. Okay, you buy 1,000. So how much do you have to pay total?
70,000.
20,000. Okay, so our total expenditure is equal to the price multiplied by the quantity. That is equal to that example 70,000. All right. Now, what is the income to the firms? How much the firm get in terms of revenue? They sell 70. They sell at the price of 70 ringgit, per unit, and then they sell 1,000 durian. So how much do they get? Do the firms get? If you are the seller, how much do you get? The sellers?
70,000.
70,000. So the total expenditure from the consumers, us, that will be equal to the total income, total revenue to the firm, sama 70,000. Okay. So now, what is the consumer surplus? The consumer surplus is the extra benefit to the consumers. Okay. So consumer surplus is the extra benefit, or sometimes we call it net gain. Okay, extra benefit to whom? To consumers. Okay, above their expenditure. Okay, so their expenditure is 70,000. All right, the expenditure is 70,000, which is what? Which is the rectangle. Okay. Now on top of it, there is extra benefit to the consumers, and that is shown by that area. So that area, the triangle, something like triangle, is the consumer surplus. So what is it? It's the area under the demand curve above the market price. So what is it? It's the area, okay, the area between the demand curve and what? And the market price. From where? From 0 to XE. So we are talking about the interval 0 XE. Okay, so that is the area under the demand above the price, equilibrium price, or the area between the demand function and the equilibrium price. In terms of integral, it will be the integral from 0 to XE, the demand function, dx, minus the integral from 0 to XE of PE dx. So sometimes, you don't have to put the word dx, just put d. So for short, you can put just d. Simplify, simpler to write. So that is our extra benefit. Okay, our extra benefit, that means extra benefit to consumers above their expenditure. And it is the integral of the demand curve from 0 to the market quantity minus the integral of the market price from 0 to the equilibrium quantity. Okay, all right. Any question? So you have to know the price on the demand function. Okay, I will talk a little bit about the this benefit. So the price under the demand function, what does it mean? Okay, price P on the demand function. It's the price of what? It's the price we are willing to pay. Okay, how much you value it? The price I'm willing to pay for a given quantity. All right. So that is the price I'm willing to pay. That is the price on the demand function. The price, which is the market price, the equilibrium price, what is it? It is the price that we pay. Okay, that is the paid price. You actually pay that price. Okay, you paid that price. What do I get? You paid PE. We get XC, not just I get, everybody gets. Okay, all right. The price on the demand is the price you are willing to pay. PE is the price that you actually pay to get that quantity. Okay, all right. So let's go back to the graph. How do you get the extra benefit? Now, let's suppose I consider some quantity, say the first 1 unit. This is the first durian. Alamak, oh, yalah, internet.